Hello, can you hear me?
Yeah, I can. Can you hear me?
Yeah, now I can hear you. So, which topic you want to start?
Um, that you have to tell me because you just refresh some of the basic things.
Which, which one?
Some basic because I hardly remember
Sure. So, in
calculus.
basics, I'm going to tell you matrix, differentiation, integration, sets, relation, function. Which topic you want?
You start with calculus differentiation and other things.
Your voice is very slow, so can't hear you clearly.
Can you hear me now?
Yes, I can hear you now. Yeah.
Maybe actually there are two problems. One, my speaker is not working. Second one is my
Okay.
voice is not good today. So just bear
It's
with
okay.
me for today and tomorrow. Maybe I'll ready my speaker by tomorrow itself. Okay, as I mentioned, you refresh the basic things like I hardly remember the calculus, trigonometry, statistics, everything. So if you just refresh everything, then we can start with
Calculus?
a calculus, trigonometry. I'm not sure whether it's required or not, but calculus and statistics, if you refresh, it is well and good.
Again, your voice. Can you type me on WhatsApp? Actually, again, your voice is breaking.
What about now?
Your voice
Can
is
you hear me?
very slow, not clearly audible. So you can type. You can type me here and also on WhatsApp if you want. Okay.
Sure.
So shall we start with matrices, or you want? Okay. So let's start with matrix. Can you see the whiteboard?
Yeah, I can.
Okay. So let us understand matrix. What is it? You know very well, but just we are going to refresh it. Matrix, a rectangular arrangement of element, is said to be matrix. Matrix A having element A, B, C, D, E, F. And we can say in another way also, if we arrange elements in rows and columns, horizontal arrangement is said to be row and vertical arrangement is said to be column. So either we can say a rectangular arrangement of elements because A, B, C, D, E, F are elements and this A is said to be matrix. When we arrange elements into rectangular form, then we can say this is matrix. Okay. Or we can say in another way that if we arrange elements in rows, we have two rows, two horizontal arrangements. Okay. So we say these are two rows. And three, we have vertical arrangements. So we can say we have three columns. Got it?
Yes. Can you hear me?
So this representation is said to be matrix. Yeah, I can hear you, but sometime your voice break. Okay, not an issue. You can just type me in inbox. Okay. So now next topic is order of a matrix. Sure. See, when we learn in data science, then we use it very broadly. Okay. because any matrix can be represented in the form of vectors. And in data science we use, and in statistics we use values or we use points, but in data science we use vectors instead of points or values. Okay, so here, as we have three columns and we use these three columns as a vectors. Okay, so we use very broadly. Okay, in data science further. Okay, in real life we can find unknown values in finance, in business and finance. We use this matrix. Further we'll do how can we use it. Okay, or we can find or like unknown values, like based on profit loss and production. We'll use this further. Okay, when we when we'll do application of matrices, then we'll do question related to that. Okay, you got it. Yeah, I'll give you notes also along with it, in which we have theoretical portion also. Means it's application where we use. I'll explain you by using that theoretical portion also. So now next topic, order of a matrix is equal to number of rows into number of columns. So here we have two rows and three columns. So its order is, we write order here. It's 2 by 3. We read only 2 by 3, not 6. Okay. We read its order 2 by 3. So it is 2 by 3. Next, we have topic types of matrices. You got it till here? Okay. Types of matrices. Matrices, just plural form of matrix. You know very well. So first type is row matrix. So a matrix is said to be, or we can say a matrix having only one row is said to be row matrix. For example, here we have only single row having elements x, y, z. Here we have three columns, but we have only single row. So this is an example of row matrix. And we can take one more example, matrix B, having elements 2 and 3. We have here two columns, but having only one row. So these two are examples of row matrix. Next type is column matrix. Similarly, if we have single column in a matrix, then we say this is column matrix. So a matrix having only one column. is said to be column matrix. For example, matrix C having single column, having element ABC, and here we have three rows but having only single column. Here we have two rows but having only single column. So these two are examples of column matrices. Okay, got it? Next is square matrix. A matrix, in square matrix we have equal number of rows and column. So a matrix having equal number of rows and column is said to be square matrix. So let us take examples. Having elements A, B, C, D. So here we have two rows and two columns. Okay, and its order is 2 by 2. And let us take one more example of 3 by 3. Having A1, B1, C1, A2, B2, C2, A3, B3, and C3. You got it now? Shall we do the next? Okay. Next type is diagonal matrix. So in this is also a square matrix in which we have diagonal element, only diagonal elements non-zero and all other are 0, 0. So for example, diagonal matrix D, see, only diagonal elements are non-zero means these are diagonal elements. Arrangement in this way is said to be diagonal. Okay, so only diagonal elements are non-zero in diagonal matrix and all other on both sides of it are 0, 0. Okay, so this is diagonal matrix. Got it? Okay. Next
Yes.
is scalar matrix. Next type is scalar matrix. So scalar matrix is also a type of diagonal matrix in which all elements of diagonal are same, like matrix S having like 5 0 0 0 5 0 0 0 5. So we have diagonal, all elements are same in diagonal. So this type of matrix is said to be scalar matrix. And we can take also of 2 by 2 like 3 0 0 3. So this is of 2 by 2 order, and same way we can see here, matrix C having elements x and y, only non-zero diagonal elements here. So you got it, both of
Yes.
All right. So let us do the next type, identity matrix. So identity matrix is always denoted by I, and here only here this is also a type of diagonal matrix in which we have diagonal elements only one, like 1 0 0 0 0 0 0 1. Identity matrix, this is also known as unit matrix. Okay, right side is not allowing this file. One second. Also, unit, yes, identity matrix or unit matrix. This is of 3 by 3. Sometime they can ask you, or sometime you'll have this I3 in any question. I3 means identity matrix of 3 by 3 order. Similarly, I2 or just most common symbol is I only, but sometime we have this symbol. So this means 3 by 3 means identity matrix or unit matrix of 3 by 3 order. And this means of 2 by 2 order. Or usually we use the symbol I only. 1001. Got it?
Yes.
Next, next type we have zero matrix or null matrix. Or null matrix. See, we can use any alphabet for all other matrices except identity and zero matrix, because identity matrix is always denoted by I and zero matrix is always denoted by O. See, this must be square matrix, okay? But in zero matrix, we can have any order. But having all elements 0, 0, always. It is always denoted by O and having elements 0, 0. Okay?
Yes.
Further types based on operations. So, first of all, we learn operation on matrices, then we'll do rest of types. Okay?
Okay.
So, first operation, transpose of a matrix. Okay, before that, I'm telling you how to form a matrix if we have elements type or elements formula. How can we form a matrix? And then we'll do this. Wait for a moment. And standard form of a matrix. First of all, we'll do that. Form of a matrix. See. So let matrix A. This is elements. We are writing in this way. See, first element A11. It represent, this is element of first row and first column. See, first number represent row and second represent column. So this is element of first row and first column, and this is element of first row and second column, because we take rows horizontally and column vertically. So this is element of first row and first column. This is element of first row and second column. This is element of first row and third column, and up to, this is element of first row but nth column. This is element of second row but of first column. This is element of second row and second column. This is element of second row and third column, and up to, this is element of second row and third column. And let us take one more. We can take also. This is element of third row and first column, third row and second column, and this is of third column, up to element of third row and nth column, and up to mth row and first column. This is element of mth row and second column. This is element of mth row and third column, and up to, so on till to mth row and nth column. This is a standard form of a matrix. M and N are unknown values. We can take like 4 and but usually we calculate most probably for 3 by 3. Okay, n by n we'll use further in data science, but for basics we use up to 3 by 3 only. Okay, so if we have elements formula, then how can we construct a matrix? How can we form or how can we construct a matrix? So let us understand this. Are you getting me?
Yes, yes.
If you want to ask, you can try me. I'll explain you again, okay?
Sure, sure.
So, construct, we have like, mm, we have question, construct a 2 by 3 or 3 by 3, any of any order matrix if Aij is equal to I plus j. So we need to construct a matrix of 2 by 3 means, so we have 2 rows and 3 columns, and we need to construct this. I'm telling you what it means. Aij means just represent element. We'll form further. What it mean? Like we have 2 rows, so just put an I is a I and j is equal to, see, we have values of I means I represent row and j represent column. So we have values of I, obviously 1 and 2, and values of j 1, 2, and 3, because this represent row and represent column. So we can represent this matrix, required matrix, in this form. We need A11, A12, A13, because we have 3 columns, A21, A22, A to 3. Sorry, A to 2 and A to 3, because we need 2 rows and 3 columns. Now we need to find these elements, okay, by using this formula. So let us find it. So what it mean by A plus J? I'm telling you, or they'll give you, or you will have formula in further question like this, or in a state of I plus J, you will have I plus 2J, I minus J, in any form. Then how will we use? So for A11, we have I is 1 and J also 1. So just put here 1 plus 1. So A11 is 2, because we have this formula, or we have this rule, you can say formula or rule. Then A12 means we'll put here I is 1 and J is 2. So we have 3. A13, I is 1 and J is 3. So we have 4. A21, A21 means I is 2 and J is 1. So we have 3. And A22, both we have 2. So 2 plus 2, we have 4. And A23 means I is 2 and J is 3. So we have 5. Are you getting me?
Yes, yes.
Alright. Now we need to put value here to construct required matrix. So let matrix A, we need to construct. So required matrix A is having here A11. A11 is 2. A12 we have 3. A13 we have 4. A12, A13. Next A21, 3, 4, and we have 5. So 3, 4, and 5. So this is required matrix. You got it now? How can we construct a matrix?
Yes, yes.
All right. So what do you say? Is it enough for demo today, or you want more?
No, this is fine for me.
If you want more, then we can continue. Okay?
No, this is enough, enough, enough. But
I
I
can't
have,
hear you at all. Can you type me here? I can't hear you.
I will.
You want to continue? Okay, I'm telling you one more thing where you can check this saved whiteboard and this recorded lecture. I'm going to share your screen so that you can revise this. Okay, just a second.